Hi, my name is Ken Mollison with Entisys Solutions. We're premier partners with HP, and HP's graciously provided us 2 strategic big data strategists. Put a double on that, but they're here to discuss the impact of big data on the data center, and you'll see that HP gets big data. And after, if you want to go back out, we're the ones with the coffee cart out there. You can come by and say hi or just have a cup of coffee. Thanks.
Well, thank you and good afternoon. Thank you, Ken, for the introduction. Thank you for Entisys to sponsor this session. My name is Ben Yang, and along with me is Bob Wisnowski. And we are in the HP Big Data Solutions team. And we are specifically in the domain of infrastructure for big data. So how many of you are infrastructure engineers and architects in this room? How many of you are data scientists in this room? I think these are data scientists specifically are really in big demand. So today I want to, this is the session that basically we want to talk about the big data impacts on data center infrastructure. And especially, the storage, how you store those data, and of course, we're going to touch on the processing, CPU memory. Hopefully that's not, we only have 45 minutes, so we don't have a lot of time to go into the details of, each step, how you do this, that we're going to address. Hopefully we're going to provide you with a set of questions that you have to go through. When you think about big data impact on data center, you know what set of questions you can ask, and some of the technologies, hopefully we can answer some of the questions as well. So big data, to make it really concrete, right? So IDC predicted that, in 2020, we're going to have 40 zettabytes of data. Nobody knows what 40 zettabyte is, right? So let me tell you, 1 zettabyte, you go to Fry's, right? You get 4 terabyte drives. And you can fill those 4 terabyte drives into your 1U servers for the football size. And the cost is 1/3 of the global GDP. That's how a zettabyte of data. Okay, in 2012, IDC predicted 1.8 zettabytes of data. Last year, 2.7. 6 years from now, 40 zettabytes of data. Think about that. That's the right side of the picture, right? So if we look at this data growth, some of the data is very conventional, and people, I'm pretty sure you know, some of them are Oracle, SAP, SQL, and some of the things that we've been very familiar with in the last, 20 years, right? And other data, however, it's a little bit unknown. All right. However, the data coming from the video, the 2 cameras there, from my mobile phone, all those data are new, okay? And almost every sector of the industry experience those, including the government. We put in some examples of, California government have been working with the big data. And actually, this is not only California government. This is actually a global, worldwide federal initiative called Datagov. And it is sponsored by United Nations, by the World Bank, and many countries across all the continents are addressing those. Right? Information maintained by federal government is a national asset, what Obama said in 2009. It's echoed by many governments. And what really does, when government release data, right? So I go into San Francisco airport, pick up my friends. I know exactly where the flight is. Guess what? Because the FAA released that information. It becomes public information. So GPS, right? The Defense Department released the GPS. So we can create the GPS business, right? Private sector get employment, get economic benefits from that. National defense, how we decode the secret of Boston bombing, face matching technology, big data, right? So all these are in there, and lots of different scenarios. I don't want to explore there because the session's focus is how does that impact the data center infrastructure. So to recap, in the middle you can see the IDC 40 zettabytes of data growth. And as I said, there are many different data that we collect today that's not there before. Think about Facebook, Twitter, I don't know how, LinkedIn, how did we find jobs? I don't know how we can survive, but I survived. 20 years ago when I was looking for a job, I didn't have LinkedIn, right? And particularly I want to point out is the dark data. You can see on the upper right-hand corner, the darker data is really growing fast. What are the dark data, right? Dark data actually is, if some of you are system administrators, right? So the event logs. What were we looking for in event logs before? We're looking for failures of authentication, application startup failures, service failures, all those things. The rest of the things, the other data events, we throw them away, right? We set a policy of how much you can keep the log data file, right? And what's the policy you can recycle and delete the earlier events, right? However, the dark data, the machine-generated data like event log, now is being utilized. We keep the entirety of the data, every entry, to predict when the system is going to fail, to study, to see the patterns, right? So those data events, the log events that we used to throw away, now is being utilized to predict the failure before the failure happens, so that you never see a failure, hopefully, theoretically. Not possible, but. So that's the one example of big data. Lots of our cars, our phones, everything. Soon, the refrigerator is going to generate data in your house, right? So these are the dark data. So really, how do we do this? How does that impact our data center? We summarize in the 3 R's. Return of information. That means that how we capture the data and make the value out of it, right? Return of information. Return of infrastructure. This is how to support this return of information, we need the infrastructure, right? So we got to get the infrastructure. And very importantly is the people aspects, the skills, the knowledge, and also how do you make your work efficiently. The newer technologies and newer skills. If you search job searching website, right? You're going to see things like Hadoop, NoSQL, all these are popular terms and giving you big money, right? People are paying big money for it. So that means the skill that we have to change, skill set we have to change. Instead of managing, several hundred gigabytes of data, now you need a single FTE to managing, not only, terabytes, possibly petabytes of data. Okay. So some of the technologies I throw in the course, kind of a very messy, slides there. But I want to point out that some of the key terms that we need to know as infrastructure architects, infrastructure engineers, things like Hadoop file system, HDFS, okay? And some of the other thing is object storage. And interesting enough, there are, just pick a few, erasure coding. Anybody know what erasure coding is? No? Erasure coding, and anybody knows RAID? RAID technology, right? So RAID is you put several disks together and you get some, error correction and checksum on some disks. So when one disk fails, the other disk can kick in and, repair that data. Now that repair technology used to be in the storage arrays among a few drives, now extended itself to multiple computer nodes. And more erasure coding actually beyond that is between data centers. So think about your read technology self-correcting among few spindles, now going to different geographic sites. And that's what Google has been doing, and that's what Facebook is looking at, right? And huge scale. So these are just some of the just pick a few items there. RAIN, I can't remember where RAIN is. But RAIN, R-A-I-N, stands for redundant array of independent nodes instead of disks, right? So give you some of the terms there. And this is really, if anybody heard about the term called software-defined storage, really, lead to you about software-defined storage instead of building on the array controllers. Now, some of those technology change really changed the landscape of storage. And lots of our management is looking at the cost structure. The cost structure actually is heavily impacted by this big data movement, like Hadoop, like NoSQL, like object storage, right? And if you look at the yellow bubble on the left, that's the traditional SAN storage area network in NAS. We've been known for decades, right? And I remember in 2000, I entered into a press release by Hitachi Data System on their Thunder platform. It's 36.4 gigabyte drive, 15K. The speed never changed. All right, how much that drive cost? $5,500. So that's over $300 per gig. And what we're looking at today, we're looking at 30 cents. If you look at the bubble in the middle, kind of a gray, that's the scale of NAS that was popular in the last maybe 5-6 years. And really from 2011, when I dragged into a project by a telco company, a cell phone maker, European company, and asked me to look at a project that normally storage guys would not pick up. That's called Hadoop. They were looking for 30 cents per gig in 2011. And they're looking at 2 petabytes of storage. And today, very, very common at the very bottom, people are looking for 10 to 10 cents, 15 cents per gig. Okay, so that's what happens when you have big data impacting the infrastructure cost. Of course, this is more than just infrastructure cost. It's involved with the processing, a journey of your IT, of your enterprise IT workshop, whether it's government or private sector. And first of all, you need to simplify the infrastructure. You have to standardize. And you have to standardize on your application, standardize on your hardware, standardize on your operating system, not to 1, but maybe from 10 to 5, to 5 to 2 or 3. And afterwards, you need to virtualize it, right? Virtualize means that you want to take even the 2 or 3 platforms that you have, simplify it, abstract out of the physical, and becomes all logical, right? Why do we do this? After we do standardize, virtualize, now we can put into a self-service infrastructure. That means you can provisioning your pools, whether it's storage, server, or networking, into a policy-based pool that you can automatically provision and deploy. After we do the infrastructure, self-service, you can see on the 4th step and 5th step, is your application guys no longer coming to the infrastructure guys saying, hey, I need some storage, I need some Unix platform, or I need some Windows platform, because it's all in your website. They can go and click. If they do the policy, you're going to get approved within a few seconds, a few minutes, maybe half a day, and your infrastructure is ready. Okay. And of course, the last box is not only you do it in your own data center, but also in the cloud. Outside of your data center, not only your data, but the data in Facebook, the data in Twitter, and data in LinkedIn to support your enterprise needs. Okay. To go further, as I said in the beginning, that we need to train ourselves to ask a set of questions. What do we need to do? This is too short of a session to provide answers, detailed. But we can ask, in the 4 domains: mobility, BYOD, bring your own device; security, cloud, and big data. And there are 4 domains that you need to ask questions for. One is the set of questions for architectures and applications, and things like Hadoop, NoSQL database, columnar database, those kind of things that you need to go and ask. And all those applications and architecture platforms, you need to deploy some newer technologies because the traditional technology will no longer work. Right? So these technologies, including disk, CPU, memory. HP launched a microserver. How do I define microserver, right? 4U space, 5U space, and you have 180 server, 60 servers. And server cartridges are in the size of your I/O cards on your desktop. These are the newer technologies that process those big data, right? And then, of course, when you have those technologies, how you deploy them and make them work in a data center and in consideration of power and cooling, space, density, right? So these are the questions you need to ask. And there are newer technologies in the data center itself, like container data centers called pods, eco-pods. So you can, these are like mobile homes. You drag on your truck, put in your data center. You can replace your current data center, extend your current data center, and whatever you want to do, eco-pods, right? So the lots of design for private and public cloud. What do you want to do overall? So these are the set of questions, and you can ask yourself, and whether go to your vendor, go to a partner. One more example, how you implement a data center like a EcoPod, and you can do whether it's a blade server, pizza server, whether it's a traditional server, and power into a pod, and you can process MapReduce, which is one of the things that Hadoop essentially does. And when you, if you don't understand MapReduce, that basically when you Google a word, right? So it searches many different documents. It parses the documents to get into individual words and then summarize them again. So that's called map. So the decomposition of words is map, and when you return the results, how many of them, and most of the popular words, called reduce, right? So MapReduce can be done in the public or private cloud, and this is one of the infrastructures we can do, and very popular today, right? I'm not going to have time to drill into the details. Next one is you can do failover between MapReduce, either in physical, customized way, or you can do it in cloud. And really, Hadoop, when you think about it, is a combination of storage, server, and networking together, and the cluster communication in between, and how they make it work, right? So converged infrastructure is really the key in there. Not only we no longer support server as individual, silos, or storage as individual silos. All of them, big data and cloud will bring all of them together. It's called converged infrastructure. So let me drill down one more. This is my last slide, about give you a concrete example how Hadoop changed the landscape of data center, infrastructure. So we have, networking, we have storage, and we have compute. So if you look at traditional enterprise data warehousing, if you look at very far left is the traditional SAN and NAS. your traditional database, Oracle, SAP, SQL, those data, right? You input in there, you abstract those data out, going through an abstract load process, ETL, through the network, and then entered into the enterprise data warehouse. The loading process in the middle can take a few hours, depending on the amount of data, can take days, right? And then you do your traditional business intelligence work on that. Now, how does that Hadoop transform and actually totally change the landscape? Hadoop, we're processing like Google, petabytes of data a day. How do we do that? The traditional work, enterprise data warehousing model doesn't work anymore. So we need to bring, number one is to bring data closer to the CPU. How do we do that? DAX, right? Now, the traditional ETL process, lots of networking. Where does that translate into Hadoop? Clustered intercommunication between nodes. So each Hadoop node is shared nothing model, right? And then each node, when they finish the work, they have to let the cluster know, I'm done. Next, right? So this is what, being very popular in the last 3 years, coming into customized Hadoop data warehouse kind of thing, all right? Where is the leading edge technology going? To move this workload, compute and CPU, into the cloud. How do we do that? So that really go into the cloud model. So you can see on the left is the storage, cloud data, normally it's object storage. Why in the cloud? Think about when we shop. Where does the data go? Internet, right? Cloud. When you enter government, going to, pay my property tax, where does that go? Internet. So the data is already in the internet. How do we get to the data? From the internet, object storage, Dropbox, right? Amazon, S3, go into the compute and establish a failure domain, fail over, all the models works in the cloud. So I'm going to stop my portion and let Bob finish.
Thanks, Van. Again, I'm Bob Wisnowski. I'm part of the same big data solutions team at Hewlett-Packard. And we're going to talk a little more detail behind the cloud and big data and how it impacts the data center here. I want to give you an example, and I apologize, some of the fonts seem to grow on this, so we're having an overlap on some of these slides, so I apologize for that. But now this explains a little bit of what HP did in their own IT department using some cloud automation tools to provide a database environment to the applications team. And what they learned by automating it is that they were able to go from 45 days down to minutes, and as well as improve the utilization using a common infrastructure, being able to reuse the platforms, be able to get better density, and really lower the cost to doing this. So they were able to achieve multiple things by automating this infrastructure to be able to provide database as a service right to the applications teams. So this is something to keep in mind as Van was explaining how cloud and big data is coming together here. This is a perfect example, just even at Hewlett-Packard, on how we were able to reduce time and get better efficiencies. Now, some strategies you got to think about here as you're going and as you're looking through this, as Van explained too, it's understanding that content creation, some of that extract process, maybe classification of data, where I'm going to load it, where I'm going to stage it, how I'm going to take advantage of some of this infrastructure out there. And some of it you might want to take a look and understand the business needs a little closer. Look at the ways I can extract that information, some of the tools that best fit your business need right up front. Some of the flexible schemas of which, when I look at this data, how I can absorb it and put it right into the database itself. And look at different low-cost, more efficient ways, as Van explained, bringing that data, bringing the storage and servers together allows you to really reduce some of those costs, provide much quicker, reducing some of the latency behind it all, as well as, taking into consideration the networks, having an open flow to it, being able to customize the types of networks, have more flexibility in how I grow that network. So I start to use these common infrastructures, some new approaches for analytics here with columnar-type databases, taking a look at my security and recoverability aspect of that. When I look at what converged infrastructure brings to the table, I look at open standards, trying to bring in, things that don't lock me into just one way of doing things. It allows me to take advantage of new innovations out there, take advantage of new infrastructures, and allow you to grow, allow you to innovate better in your own business. So one of the things is the traffic patterns we look at for data centers, right? So if I look at Hadoop here, I know that Hadoop is sort of like a file, is sort of like a storage system for me as well. It's going to do my replications, it's going to do my high availability, and the traffic patterns I look at are going to be replicating between nodes, between all the nodes in that rack. So I'm looking at more traffic patterns from an east to west type of delivery between talking with that application than going north and south, up and down, going out to my switch infrastructure and back. And as it goes the same with, clustering. When I cluster things together, I can have hundreds, thousands of Hadoop nodes clustered together. Again, they need to talk between each other, so you're going to get better east to west type of traffic patterns through these types of technologies. So this is something to keep in mind and consider as you're looking at your data center, looking at the impacts to your data center. How am I going to design that? So I want to think about flatter, more simpler types of data center fabrics to improve performance, reduce that latency, reduce the cost. Not have to go all the way up and down the infrastructure to communicate to all the nodes in that cluster. So I want to be able to simplify it, go between the servers, the nodes itself, be able to reduce cost, lower the total cost of ownership, but again, reduce latency between all of this. So looking at the differences between east to west traffic or traditional, the way we've done networking in the past. So here's another example of converged systems using all of those servers, storage, and networks together, and looking at how we were able to, really build a use case, use a 10 terabyte platform here, and provide a sort platform for Hadoop, and create a very fast, efficient way to do that, all within a frame of a server itself. In this case here, multiple servers with 15 disk drives per node. So I've got 45 to 50 disk drives within a 4 or 5U area here. So again, converged systems, being able to do more with in a smaller footprint. Allows me to save on power cooling. It allows me to really automate better. And I have the tools to manage it, so I can manage the infrastructure, I can manage the metrics from the application itself. So there's a lot of other examples of use cases for these types of technologies like Hadoop or other technologies that are out there. And these are ways that you can look at converged systems to speed up the deployment of producing the system that you need. So all of this needs an architectural model. So we look at it as a data ocean out there, rather than just a lake or reservoir for the data. We need to look at it much broader, much deeper. So we look at it from a three-dimensional view, looking at the breadth of what you need for a data ocean. Requires people, all right? That culture, the governance behind it, that organizational structure. It also requires a process, the understanding of the data science, the computational or mathematical sciences behind it, and looking at how I'm going to deliver the analytics and application, but also the technology behind it. So looking at the technology, the application view, the execution, the operation, we consider, more of a three-dimensional view of what you need to look at when you're building that data center out. Also, the depth. When I look at, the depth being, the business layer, the process layer, coming together, integration points, and implementation, trying to bring it all together. Use the entire supply chain that you have in a vendor, as well as within the resources you have within your own business. But having that depth and having the fluidity to grow and shrink when I need to. Again, reuse some of that infrastructure when I need to. The automation of that. To be able to do the MapReduces or consolidations that I need to do to look at that data. Let's take that architecture model one step further. Let's take a look at how we can add a platform at the core to support that data ocean. Looking at, some of the needs that I have out there, that unstructured or semi-structured or unknown structures, to be able to collect all the data that I need in one spot, to be able, again, maybe even create some content awareness around the data, to catalog it, to get some classification of what I need here. Also, the flexibility to analyze extreme scales of data, to be able to get that speed out of it, to be able to have the right tools for the right, the right job. And also to wrap it around, with security and the number of applications. So again, looking at all the types of data that you have coming into this, providing all of that infrastructure. This is what HP calls Haven. Haven is a grouping of different products that are out there, again, giving you choice in Hadoop infrastructures, looking at the type of infrastructure you want to use. There's many different distributions of infrastructure, so we use a very open approach to allowing customers to choose what they need and what tools they need. Again, offer some additional tools to support that classification model, to allow your users to be able to get quick analysis of the data that they're gathering, as well as the extreme scale of volume, to have a columnar-based type of infrastructure with a flexible schema. So as I'm reading this information into an infrastructure, I can now start to process it very fast, very efficiently. And again, with the right levels of security, the right number of applications, your applications. Again, it's your agenda, not our agenda. It's an open infrastructure that allows you to put together the types of tools you need for your applications. As an example with connectors and integration for this data ocean, having that ability to really use Hadoop, use all the different applications that you might need, the right tool for the right job, integrated with the security, integrated with the analytics, maybe even some data enrichment and visualization tools, so you can now process it much more efficiently. And again, as you think about it, look at all the data that I've got to collect. Again, keep in mind, the more data I collect, this traditional amount of data, the big data, the dark data, accuracy and insight come from the volume of data that I'm able to collect and have the right infrastructure that I can move that data around, have that mobility to move data around. So if I look at that, we have different connectors that are available in this platform called Haven. Haven allows me to take data in from the internet, in from the web, and put it into an infrastructure, into a Hadoop infrastructure that allows me to store that data. But I can also bring data into other tools like Vertica directly, and I can move data with integration and connectors between all these to be able to move data between Hadoop and our database called Vertica, as well as between Autonomy and the internet, as well as between Hadoop and Autonomy and Vertica. So it gives you that ability to have integration, connection points to an open architecture, an open platform that allows you to grow, have the right tools for the right job. So as we look at a use case here, some of the things we can do in this for the for a federal government agency, some of the capabilities on the right-hand side you can see, and on the left-hand side we kind of drew a small outline of some of the things that we have to look at and pull this information. So some of these are just data sources from all different areas, having GPS availability, having all different social media, being able to collect all this information into a database, and as well as be able to process some of the customers' tools themselves, to be able to integrate it all together, as well as automate it with some infrastructure for providing, whether it's a private cloud or public cloud capability. So, some of the must-haves in the solution had to have that ability to expand it on the fly, to grow to petabytes of storage, be able to, again, keep with the economy of the technologies that we have that openness so I can take advantage of the lower cost storage and lower cost capabilities, but have the efficiencies through automation, have the ability and reliability, most of all, to provide that to my customers. So here's a deeper dive of how we use this platform called Haven to accomplish some of that. Some of it with, again, reference architecture points, some with different data structures out there, as well as the automation and integration to other platforms the customer had. Along with our whole supply chain within HP and our partners, to be able to bring it all together so we can provide that infrastructure, those data sources, that ability to move data into Hadoop, as well as move it back and forth into a columnar infrastructure that allowed for the analytics, the speed behind that as well. So this was just an example of what we did for one of the government agencies in that use case. This also shows in that architecture model that I talked about earlier, that breadth and depth of how we use our whole organization, our whole infrastructure, the whole supply chain, including our partners, including the customer, to be able to bring it all together. Because, again, it's your agenda, not our agenda. It's something we're providing the right set of tools for the right job. So I'm going to wrap it up here with a few slides here. One of them, again, we won't go into the demos themselves, but you can go out to the web. You can download this as a PDF and go to this web link here, and you'll see there's about a 60-minute demo on how HP did a clickstream type of analysis over the web. So again, the value of that, what it brought to, how it impacted the organization. As well as there's one on social media on how the analytics portion of that allowed you to look at some Twitter feeds coming out there, understand the sentiments of some of this and how that might apply to different things, different areas, even in the government, on how you might use that in a different way. So these are just some examples to look at. What I'd like to do is just wrap it up by just talking about addressing big data impacts on the data center through, what is your return on investments to the power of 3 here? What is the return on information? Making better decisions, but understanding that data ocean that you require, the volume, the velocity, the variety of data that I need, and having the right architecture model to support a data ocean like that. So to get the better return on information, having the right tools, having the right architecture, the right strategy up front, the openness that it provides. Also, the return on infrastructure, which lowers the cost, lowers and boosts your agility, the ease in which you do things, right? That saves time, that saves individuals, that saves on the complexity, right? More I can standardize, more I can optimize on that, that's going to provide me really a better return on infrastructure, information, and individuals. Which all really, it's the return on investments, it's your time to value. It's if we're trying to reduce costs, we're trying to save lives, we're trying to do different things within our own departments, I've got to look at different ways to do that, different media. And looking at how my data center takes advantage of this big data is one of the ways. So hopefully that was what you were looking for out of this session. Again, as Van explained earlier, if you want to go deeper dives, certainly drop by the Entisys booth, booth 26, right in the center here, as well as, there's an HP booth, booth 9, that you can drop by. So, if you need help, that's what we're here for. We're here to help, discuss this in deeper sessions, deeper dives. So hopefully this has been helpful for you. So if there's any questions, we'll take any questions now. Nobody's got a question after all of that? Okay, well, we'll give you some time. Go ahead.
As in some of these, can you use that software as a service and you're sort of bursting out to cloud-based infrastructure that you're going to be using as a piece of this technology?
So the question is, can we use software as a service? Can we use some of this later on? And that is a key question. And that's why we talk about cloud and big data coming together here, because it is about that automation phase of it. It is about bringing the data and servers closer together. It is about automating it, making it easier for the departments to get their information, making it easier to have self-service. And when I need to burst out, sometimes I don't have all the resources in my infrastructure, so bringing the cloud closer in that respect, having the ability to take some of these and burst out to another public cloud is key. So having the right infrastructures, the right technologies, that open source that we talked about, that open stack, having similarities, having a common platform which I can share data, move it along, orchestrate it, and optimize it is key in all of this. So, these are things we can go deeper dives in, and later on, if that's some of the areas you want to get into, that's something you can stop by. So that's basically all I have, unless there's any other questions. Well, thank you all for coming. We really appreciate it, and hopefully you have some good experiences out of this and use this information wisely. So, thank you again.